Okay, let's look at some problems for chapter 6. The first problem is really very simple, just trying to identify yield to maturity from prices. So what we have here is some 4 different bonds, and here are some dollar prices of these bonds, and they are $100 face value bonds. Now, how this works in reality, most bonds are not $100 face. Most of the time they're $1,000 face value. And usually the prices are not stated in dollars, but stated in percentages. So in this case, the percentages would be the same. They just wouldn't have the dollar sign, they'd have a percent sign. So this 1-year bond, in reality, this would say 98.04% of 1,000. So if it's 98.04% of 100, that's $98.04. But in reality, if it's a $1,000 bond, this would be $980.40 for a $1,000 face bond. You move the decimal place 1 point. So as we look, we just need to input the data into some form of a spreadsheet or a formula. We have the bond valuation worksheet where you input the par value. In this case, it's $100, and the price, $98.04. It's a 1 year to maturity, and it solves over here for the yield to maturity here, which is 2.0%. So if you buy this bond at $98.04, you would earn 2% this year as the yield on that investment. The other bond the other bonds were multiple year bonds. So if you paid $95.18 for a 2-year bond, we would have to change the data. You'd put the price here, $95.18, but you'd have to change the time to maturity to 2. If you did that, that answer would be 2.5% is the average yield to maturity per year over the life of this investment. So again, you can solve for that and plug in the data as you will to make sure that your answers coincide with the answers down below. The second kind of problem looks at what's referred to as a corporate bond. In this case, we're going to look at a semi-annual bond. Now, really, the difference between these semi-annual and annual bonds all has to do with compounding frequency. In this case, bonds typically do pay bond interest semi-annually. So in normal instances, this should be a 2. But you could also say it's annual. The outcomes will be different, obviously, but they're all analyzed the same. So here we have a $1,000 par value, 7 years to maturity, 9% is the coupon rate, and the price is $1,080.55. So if you look at the very first question, is what is this bond's yield to maturity? Let's look at the data first. You know it's a 9% coupon, but since we're paying a compounding frequency of 2, the coupon per period is actually 4.5%. Now in the formulas, time to maturity is also then adjusted. So it's the time to maturity is based on period. So it's 7 years, 2 periods per year. So in the formula it's used, it's actually 14 is the number that's used in the formula. So the yield to maturity on this bond is 7.5%. So what's the value of the bond if it's selling at that yield to maturity? So if you put that yield to maturity in for the required return, right? It's selling at this required return, this yield to maturity. The bond value that's published is $1,080.55. So you can, when you plug in required return, it will actually solve for the bond value. What if the company's risk factors increase the required return to 8.5%. What's going to happen to value? Well, if risk increases, we know the required return increases. So if 7.5 goes to 8.5, what happens to value? You can plug that in if you want to do this problem. If you change 7.5 to 8.5, first of all, you know that the value is going to decrease because when risk goes up, return goes up. That means the value goes down. The new value for this stock, for this bond, would be $1,025.98. So let's look at another problem. Apple has a bond, has 30 years to maturity. It's 3.75% coupon and a AA plus rating. Current quoted price is $93.399. Again, you remember from a previous slide, that is a percentage. AA plus bonds have been earning on average 3.98%. Again, assume the bond here pays interest annually. So first of all, what's the value of the bond? We need to input all the data we have in the yellow boxes. Again, remember, compounding frequency is going to be 1 because we're saying that they pay their interest on an annual basis. The value of this bond should be $960.13. But you could buy this bond for $933. So this is a good investment. We would pay $933 to get something worth $960. The yield to maturity, solve for this, is 4.14%, which basically means what? If you buy this bond, on average, you're going to earn 4.14% over the life of the investment. What is the discounter premium? Well, it's a $1,000 bond and the value is $960.13. So the discount on the value is $39 and it looks like 87 cents, right? The difference between 1,000 and 960. But if you look at the price, the difference is the discount is a little bit deeper, right? It's $66 and a penny would get you $1,000. So when you talk about discount or premium, you really talk about the difference from $1,000. If interest rates in the economy decrease by 1%, what's going to happen to the value of the bond? Well, again, when interest rates change, the required return changes. That means it's going to go down by 1%. We would expect the value of the bond to increase. So in this example, if you change the required return from 3.9 to 2.98, or 3.98 to 2.98, you'll see that the value of the bond increases, in this case, to 1151.31. So again, the valuation and the exercises with respect to bonds are actually fairly simple, right? There aren't a lot of questions, there aren't a lot of variables that we have to worry about when we're predicting values and yields. In the last problem here, we have a company has a 5% coupon, 20 years to maturity. The current price is $890. In 6 years, the deferred call can become effective, and the company will pay a call premium of $1,050. When we input the data that we know, right, what is the current yield? Well, the current yield is 5.62. This is just the coupon, the interest payment, divided by the current price. So $50 divided by $890 is 5.62%. That's the actual return you will earn the first year if you own this bond. What is the yield to call? Putting the information in the cells below, we're told that the call premium, and I just realized there's a mistake here. This says 1,080, should be 1,050. Bear with me. If you put in 1,080 here, again the wrong number, 6 years to go, the yield to call is 8.49%. And I apologize for that, but we need to also put this, make sure you understand that there is a little mistake here, right? So again, the difference here is the yield to maturity and the yield to call will rarely be the same. Would you want to buy this bond? The answer is if we know what the required return is, again, we don't know here, we can make these comparisons to the required return. Again, if the yields, if they're greater than the required return, then you would want to buy these bonds. The next question is, what is the modified duration? Remember, duration from our discussion in class, modified duration measures sensitivity to interest rate changes. How do prices change when interest rates change? So this modified duration, in this case, is 32.34. That's the modified duration. The higher the number, the greater the sensitivity, or the more change there will be in prices. So the percent change that we're talking about here is 0.025%. So make sure you enter the number so you get 0.025%, right? You have to put decimal point and then like a couple of zeros before the 25. The percent change in value then, since we have interest rates going to increase, it's positive, that means the value is going to decrease. In this case, the new price is $882.80. So that's just an example now of how bond values change when interest rates change. So if you have any issues, again, I apologize for this number to be wrong. You would type in the $1,050, and obviously the yield to call would be slightly different. So that is the fourth problem in our bond evaluation exercises.